Especially as you can see they utilized a highly innovative construction method where these massive roof sections are pre-assembled on the ground, then lifted all at once with a hydraulic device known as a strand jack to securely fasten them into position. Yes, hello everyone, this is LHI. I just got back from Google's newest campus, the Bayview campus, and this isn't just any ordinary building. First of all, its appearance is extraordinary. It's designed in a way that's completely different from the offices we're used to. The building itself is an engineering marvel, and it was fascinating how it truly embodies Google's corporate culture. Google, a company renowned for its truly distinctive culture, has woven its culture, philosophy, and future into the very fabric of this space. It was fascinating to observe how this environment facilitates research, development, service provision, and diverse discussions, embodying their vision. This building itself is meant to be a blueprint for future workplaces. So, in this video, I'll explore what culture this unique design reflects, what advanced engineering is integrated, and the structural features inside and on the roof based on my observations and research. I'll be giving you an indirect virtual tour, so let's proceed. If you look at San Francisco on Google Earth, you'll see that we typically have to go to the Bay Area, specifically San Francisco, to get to our Coral Island, correct? From here, in South Korea, below the Democratic People's Republic of Korea, I took off from Incheon and flew all the way, not to Los Angeles, but up here to San Francisco, SFO. Do you see what looks like a runway here? Yes, I landed at San Francisco International Airport. And so, what I'll discuss later, following this campus tour, will be the Stanford University tour, located in the Palo Alto area. Beyond the details of the Stanford area, if you look to the north of that, you'll discover Shoreline Park, which is typically where Google I/O events take place. And here is the Sunnyvale area where I stayed. And if you look up here, there's a center called the Google Visitor Experience, which is in the same form as Bayview. But besides that, do you see this over here? These three similar looking buildings right here. This right here is the newly constructed Google Bayview campus. When viewed in 3D, you can see its specific layout. Bayview is located right next to Stevens Creek. Do you see it here? NASA Ames Research Center. Google is very connected to NASA. There's even a runway here. In fact, Google and NASA are more than just geographical neighbors. They have a partnership. On the way to Google Bayview, you can see the NASA Ames Research Center right here. So I heard they have an important tech innovation partnership beyond a land lease. Things like AI, space exploration, air traffic control, and they'd probably need cloud computing too. In many of these areas, this NASA Ames Research Center was established almost 85 years ago. It was built in 1939, and I'm told they do a lot of research on flight simulation, aircraft design, and in IT, things like robotics and AI. The Bayview campus project drew a lot of attention in the architecture world because it's the first time Google has led the entire process from site selection and design to construction. And the question was this: the core philosophy began with the question of how to transform the office, where people spend their working hours, into a more humane environment. This implies placing the employee experience at the forefront. However, finding an immediate and clear solution to achieving this isn't straightforward, is it? So, they apparently wanted to physically embody Google's core values like collaboration, openness, and flexibility, even down to the physical appearance and structure, as though it were a living organism. That's why in the promotional video, you see things like ducks wandering around. And the three key themes in the early design stages were innovation, nature, and community. The most striking feature is this canopy-shaped roof, which is constructed from silver solar panels. It truly covers a vast expanse. Aesthetically, it even resembles a traditional Korean hanok. Wouldn't you agree? Not only does it have aesthetic elements, but it generates 40% of the campus's electricity through solar power, so it functions as a giant power plant. And it is the world's first building integrated photovoltaic system, or BIPV, as I just learned for the first time. It is made of 90,000 silver textured solar roof rolls. Its full name is Building Integrated Photovoltaics. So, the conventional method involves installing solar panels on the roof or walls after a building is already completed. But with BIPV, the solar panel itself functions directly as a construction material for roofing, exterior walls, and even windows. So, it meets both aesthetic and functional needs, with 90,000 of them embedded in this new building, like traditional roof tiles. The roof itself has what's called an inverted shell structure, where the skin faces outward. This means that its structural rigidity isn't secured until it's fully assembled. That presented significant design challenges, which is why they worked in close collaboration with the structural engineering firm, Thornton Tomasetti. Specifically, as you can see, they utilized a highly innovative construction method. These massive roof sections were first pre-assembled on the ground, then expertly lifted and secured into position using hydraulic devices known as strand jacks. The structure itself spans nearly 152 meters in width and length and weighs 2,600 tons. So they lifted it with 42 strand jacks simultaneously, which, and this is another important record, is said to be the largest roof lifting operation in the Western Hemisphere. I looked into this hydraulic method using strand jacks, and simply put, we're talking about an incredible incredibly heavy roof. To hoist this up, you can imagine it as an incredibly robust robotic arm with immensely powerful biceps, meticulously lifting it, literally inch by inch. Like a person climbing a rope with two arms pulling themselves up like this. As they pull themselves up, they grip the rope tightly with one hand and lean their body back. Then, once the body is elevated, they grasp a higher point with the other hand, release the first, and then grab further up to pull. The strand jack system operates on a very similar principle. This strand is ultimately a steel cable. You can imagine that incredibly heavy objects were lifted into place with 42 of these cables, pulling them up bit by bit. When you actually go inside, you'll see it's composed of a first and second floor. The first floor is called the marketplace, which you could think of as a sort of market. And the second floor is named neighborhood, but I can't go up there. It's only for employees, so I could only look around the first floor. On the first floor, there are things like cafes and common areas. There was a fitness center, a lounge, various meeting rooms, and also an event space. And this is a space where you can grab a drink or a snack at any time. This was a space I really liked. You can just go and grab whatever you want. Even visitors could just take things. So, it was designed as a space where employees can randomly run into each other, regardless of their team, and strike up a conversation. That's the first floor marketplace. The idea is for everyone to gather and chat like they're at a market. Anyone can book and use those meeting rooms at any time. I heard that people don't have assigned desks. The second floor neighborhood is designed around the concept of team-based districts. For instance, there would be a search division, and maybe a Gemini team. There are likely many various divisions, with each team sized around 40 to 80 members, having its own independent space that they can arrange as desired. These neighborhoods or areas are indeed separated by courtyards. These courtyards, like central gardens, are used to divide the spaces while also providing a sense of openness. They are connected by gentle ramps, which create separation, but also allows for interaction with other teams. It's a pretty interesting space. And it's called biophilic design, meaning pro-biological design. As a space embracing nature, it initially felt quite random. There are cave-like structures and even a dinosaur. This design aims to create a sense of seamless integration of natural elements, primarily to enhance the health, well-being, and productivity of employees. It features abundant natural light, sculptures that resonate with nature, and ceilings equipped with windows that have automatically adjustable shades. This allows a soft, natural light to gently filter in throughout the day. They've made sure to incorporate natural light so it feels very natural, with natural materials used abundantly throughout the space. This is to help mentally stabilize people, supporting physical well-being, creativity, and productivity. This approach is consistent across Google Korea and all their global offices. However, Bayview specifically maximizes these concepts even further. Another interesting feature is Bayview's ventilation system. It's like the building breathes. It is said that it only supplies 100% fresh outside air without using any recirculated air whatsoever. General systems usually recycle the air, constantly circulating it. They filter and circulate it, mixing it with outside air. You know, I've been swimming for almost 20 years, and since it's difficult to completely replace all the water in a swimming pool, they typically just circulate it. They combine more water to flush out buoyant elements, circulating and ventilating the space through this blending process. But if air is introduced entirely from the outside, it's comparable to continuously replacing all the water in a swimming pool. The building structure is designed that way, and things like carpets, tiles, paint, and furniture, thousands of building materials were reviewed to avoid harmful substances, often called the red list. Excluding such materials to create the indoor environment was impressive. Google has set a goal to operate on 24/7 carbon-free energy by 2030, and the Bayview campus can be seen as a place where they're actively experimenting with all sorts of advanced technologies to bring that ambitious goal to fruition. So it seems they weren't just thinking of it as a simple office, but also about a sustainable future and sustainable energy. I mentioned that the roof is powered by solar energy, right? The entire campus runs only on electricity. Combined with nearby wind farms, they say it receives 90% of its power from carbon-free energy sources. While looking into it, I found something interesting that I'd never heard of before called the duck curve. They say this duck curve is a problem in California. Do you roughly see what that means? It refers to the daily electricity demand, which takes on the shape of a duck, indicating the amount of power required. The demand actually decreases during daylight hours. During periods of maximum solar power generation, electricity supply is abundant, but during other times there's a significant demand for power. As the sun sets, the power from solar panels drops sharply, but people come home, watch TV, turn on the AC, and so on. So demand spikes, creating the steep neck of the duck. As you can see, the tiles are arranged at various angles. With its curved shape and panel orientation, it generates electricity evenly from early morning to late afternoon. This helps spread out power generation that usually peaks during the day, easing the grid's burden and mitigating the duck curve. It's It's a clever and beautiful solution that also smooths the duck curve. On top of that, it's said to have the largest geothermal energy system in North America. They applied a pretty innovative idea, using the building's foundation piles themselves as geothermal heat exchangers. Out of the 4,000 structural piles, 2,500 have geothermal loops inserted, and some of these piles are dug in as deep as 26 meters. They use the constant temperature of the ground to handle the building's heating and cooling. It also cut carbon emissions by 50% compared to old systems. And since they cut the water needed for cooling by a whopping 90%, this has the effect of saving about 5 million gallons of water a year. You couldn't do this unless you were truly serious about it. They introduced the concept of being net water positive, with the aim of returning a greater volume of water to the environment than the campus itself uses. And you know, California has desert areas and frequent droughts, so they purify rainwater and domestic wastewater from the building, enabling 100% recycling for uses such as toilets, cooling towers, and landscape irrigation systems. This also presented some really interesting elements. So, while you might simply glance at the Bayview design and consider it somewhat unique, it was actually constructed with the intention of serving as a prototype for the future of office spaces, envisioning what they might evolve into in 5, 20, or even 100 years from now. This idea that we don't know what the future holds is something Google has frankly acknowledged, and this uncertainty actually became a core design principle, leading them to experiment in many different ways. So the Google Bayview campus transcends being merely a workspace. It serves as Google's visionary blueprint for the office of tomorrow. It beautifully illustrates a seamless integration of people, nature, and technology, demonstrating genuine sustainability. It was captivating to explore how it emphatically declares, "This is the standard for future offices," all while also appreciating its innovative and aesthetic design. I wanted to cover this since it was fascinating how many cutting-edge engineering technologies were incorporated, and how well they express Google's corporate culture and philosophy. We're still releasing English versions on the international channel, Unreal Tech, so please show us a lot of support. Many of you are also following us on Instagram, where we're uploading fun videos and short clips like these. We also provide short news summaries, so you can catch up on the latest updates quickly. This has been Error. Thanks for watching.